Hello everyone, we are Group BK. Today we are presenting to you our product, Cooking Oil Fume Collector. Do you know the scientific name of the white gas? It is cooking oil fumes. Some components of it are carcinogenic. However, there is no existing product for household use available in the market which would absorb the CO before it is diffused into the indoor environment and then remove them after cooking with limited secondary pollutants generation. Therefore, we propose our device, COF collector. During cooking, the air would get in the pan through the ventilation holes, and the generated COF would be extracted through the central hole and absorbed by the device inner titanium dioxide coated absorption filters. To avoid the water mix with COF, blocking the filter hole, a water condenser structure was proposed to condense it, and the water would be collected in the water tank. The top fan was designed to control the gas flow speed. The house of the device, fitted with phase change material, was proposed to control the temperature of the device, especially the mesh, to avoid thermal expansion splitting of the coating material. After cooking, the absorbed COF could be purified by inserting the UV light after detaching the fan. However, the previous study only has shown the absorption and purification ability of titanium dioxide coating of several organic matters, but whether it could absorb COF and purify it is still not clear. So we did both the simulation and experiment to show that titanium dioxide has that ability. Let's start from the simulation. Before we start, I would like to introduce you to some basic principle. The COs need to form chemical bonds or physical bonds with the titanium dioxide surface to be absorbed. Thus, there will be an enthalpy difference in the bond forming process, and it could be used to value the affinity of COs to the surface of titanium dioxide. So, larger the enthalpy difference, higher the affinity. Several components of COFs including methyl benzene, benzaldehyde, acetaldehyde, benzanthracene, and fluoranthrene were simulated as they are the major components of COF, and they were considered as harmful and representable parts of COF. To get a reasonable structure, we did crystal structure optimization of rutile titanium dioxide based on generalized gradient approximation. Compared it with the experimental value, the result is good. Then we use the optimized structure to calculate the enthalpy difference in the absorption process. The result shows that all of the selected COF components are in favor of forming bonds with the coated material, and the absorption enthalpy are shown here. From this, we can see that the coating material has a good affinity with the selected COF components. Since the selected COF component represents the majority of COF, the coating material may have a good affinity with all COF components. Now let's talk about the actual experiment. We cut the mesh to suit the hole in the cake pan and painted it with titanium white pigment. When it is dry, the weight of the filters was measured and filters were placed in the hole. Then the pan, plastic board, and cake pan were placed in sequence as shown in the picture. Then 225 grams of beef was cooked with 9 grams of olive oil in a pan for 4 minutes, and it is covered with mock-up device, so the smoke from the pan passes through the filters. After cooking, the weight of the filter is measured, then an UV light is used to purify the filters for 30 minutes. After the purification, the weight of the filter is measured. This is the picture of the filters at different stages. This table shows the weight of the filter at different stages. It is evident that there is weight difference at every stage. Weight is gained while cooking and weight is reduced while purification. We also observe the transparent liquid droplet in the purification process. From previous studies, it is formed when the photocatalytic reaction is decomposing organic matters. Overall, the experiment shows that the COF could be absorbed by titanium dioxide coated filters and could be purified by UV light illumination. We have also generated new understandings from that experiment. Initially, we designed a house fitted with phase change material to control the temperature of the filter, avoiding any thermal expansion splitting. However, we found in the experiment the filters could be held by bare hands and they were just warm. So the thermal expansion of the material may not be an important factor, and it is not necessary to use phase change material anymore. The gas could flow out without the help of exhaust fan. The previous CFD study showed the speed would increase if we add the water condenser and water tank, so the fan could be removed. The result of the experiment also pointed out some improvements. Firstly, the shape of the filter should be cut in such a way that it fits the hole perfectly. This will prevent the leakage of the COF between the gaps. To avoid COF escaping from the holes of UV lights, the filter structure needs to be changed. In the new design, we need an additional setup for the purification. We only need to add a housing and a lid compared with the previous design. The cost will not be obviously increased and device could absorb more COF. Okay, now let's move on to the limitations. Firstly, in our proposed design, we plan to use titanium dioxide as the coating. But in the experiment, we used titanium white pigment and particle size in it is unknown. The particle size not only has an effect on the purification efficiency, but also the safety. Since the government has a strict limitation about the titanium dioxide food adhesives in size, the particle in our setup needs to meet this requirement to avoid safety issues. Secondly, in our experiment we used 2 by 2 mm mesh size for the filter. But as the size of mesh reduces, more surface area for COF to get attached, but it might block the flow of COF, so further experiments can be done to select the adequate mesh size. Thirdly, even though we have used 7 filters in our experiment, we still need to do more tests to choose the adequate number of filters. In our initial design, we have designed a water tank and condenser to collect the water avoiding being absorbed by the filter. But in this experiment, we haven't used that. So we need to do more tests with water tank and condenser to see whether it's actually needed. Finally, the test does not involve any durability test and only the beef and oil case was tested. In the real case, the selection of food and oil is various. We plan to test the water tank and condenser structure since it not only has an effect on the gas flow rate but also on the COF absorption amount. The base with the water tank and water condenser need to be fabricated as we initially proposed and tested in a 10-minute cooking test, same as the procedure we described previously except the cooking time. By observing the amount of water in the water tank, we could adjust the volume of it correspondingly. If there is little water in it, we could fabricate another base without the tank and condenser structure. If there is some water, we could reduce the volume of water tank and keep the condenser structure. If there is a lot of water, we could keep these structures as initially proposed. To conclude, from the experiment, it is evident that the filter absorbs some components of COF and during purification the absorbed matter could be purified into water and carbon dioxide. But further tests or experiments need to be done to come up with a final product which can be introduced in the market. Thank you for watching and we are happy to answer your questions.